Today's topic is point reflections. They're like line reflections, similar but different. And in particular today we're going to do a reflection in the origin. The origin, if you remember, is the point 0, 0, where the two axes, the x and y axes, cross. Right there, there's the formula. Whatever point you have, you just negate them. So let's start off with our Shaquille O'Neal point, 7, 1. According to this formula, 7, 1 is going to become -7, -1, which is over here. And the way this works is you draw a line straight from 7, 1 to the origin, and then continue that line straight to -7, -1. What you can see happening here is you go down 1, and then you go over to the left 7, so just repeat down 1, over to the left 7. I'm going to draw that line with the smartboard. And when I draw the line from 7, 1 to -7, 1, it goes right through the origin, and the origin turns out to be the midpoint of that line. Now, another thing I want to show you, if we take a point, any point, let's use the point 2, 3, and I reflect that in the origin, it's the same thing as reflecting it in the x-axis, then reflecting it in the y-axis. I'm going to draw a little circle between those two, and that's the symbol that we use when we do one transformation followed by another. The way you would read that is you reflect it in the x-axis, then the y-axis, but the strange thing about how this is done is you do the reflection in the y-axis first. So if I take this point 2, 3, and I reflect it in the y-axis first, I end up over here. So the point 2, 3 becomes the point -2, 3. Then if I take that point -2, 3 and reflect it in the x-axis, I end up down here at the point -2, -3. So you see, doing the y-axis, then the x-axis is the same thing as if I just did a reflection in the origin. You get the same answer. Now, when you do transformations, and that little circle is called composition of transformations, it does matter what order you do it in. However, in this special case, it doesn't matter. I could do the x-axis first, then the y-axis, and I'll end up in the same points. One more thing I want to show you about reflecting in the origin. Let me draw a triangle. Let's have the point 1, 1, the point 4, 1, and the point 4, 3. So we have this little triangle here. Now if I reflect that in the origin, the point 1, 1 becomes the point -1, -1. The point 4, 1 becomes the point -4, -1. And the point 4, 3 becomes the point -4, -3. And if you look at that, you can see kind of some symmetry there. And what would happen, the one way you can check if you've done point reflections correctly is you take your paper and actually turn it upside down, and the diagrams will look the same. Now if I do this one, I can turn the paper upside down. Whoop, let me, nope, I don't want that. Oh, too far, there we go. Now, let me grab this graph paper, and if I rotate it 180 degrees upside down, you can see the image is the same. Now, if you did it on your real paper, the images would move with the paper, but in this case, they don't. But that's one way to tell if you've done point reflections correctly. They have, it's called rotational symmetry. Rotational symmetry. Oh, not spelled right, there's no N in it. Let me get rid of that N. Not the N, not the T, the N. Rotational symmetry, symmetry, I think that's spelled right. And as a teacher, when I'm grading this, sometimes I'll just take the paper and turn it upside down. Now before I stop, a couple quick things. You notice the notation, it's an R with a subscript of origin. When I create the worksheets for you, sometimes that subscript does not work. Sometimes it does, sometimes it doesn't. Sometimes we'll just say R origin on one line. And the last thing I want to say is problems like this, where you actually have to graph it, it's kind of hard to do remotely, so we probably won't be doing problems like that. However, you will be doing problems where you are reflecting in the origin. So let me stop there.